Hey there everyone, and welcome to the first video of the NumPy tutorial series on the Future Programmer YouTube channel. In today's video, we're going to be installing NumPy and introducing the concept of arrays in NumPy. So without further ado, let's go ahead and get started. NumPy is arguably the most fundamental Python library in the world of data science and machine learning. And I say that because it's rare to find a data science project in Python that doesn't utilize NumPy in some way, shape, or form, either directly in our program or indirectly through some dependencies that use NumPy. NumPy stands for Numerical Python and is used to work with numerical data and big data, supporting operations in linear algebra, matrix manipulation, and a lot more. To install NumPy on our system so we can use it, we use the following command in our terminal, pip install NumPy. So I'm going to copy this line of code and open up terminal, which for Windows, which I'm on right now, is going to be the command prompt. Now I'm going to paste this command right here, pip install NumPy, into the terminal and hit enter. Now depending on your operating system, you may have to open up whatever terminal you have on your operating system, and you may have to use the command pip3 install NumPy. Now hopefully, either way, you should see a progress bar showing you the installation of NumPy, or you will just see requirement already satisfied if you have used NumPy before through a dependency or directly. And you'll also see the version of NumPy that you have installed, which doesn't really matter because all of the operations that we're going to be talking about will be supported regardless of the version of NumPy that you have. Now, if on Windows you see an error that says pip is not a recognized command, then I'll leave a link to a video on the upper right hand corner of the screen showing you how to fix that. So let's close out of our terminal and go back to this script right here. So let's talk about importing NumPy. Now, to use NumPy in a Python program, we first have to import it, which is generally done at the top of our Python file. In the industry, NumPy is usually imported under the alias np, NumPy, right? So np. The typical import statement is as follows. So import NumPy as np. After I run this line of code, now I can use NumPy as np. So whenever I say np, I'm referring to NumPy. So I can pass np into the dir function, which will give me a list of the different members of this package. And you can see there's a lot of different things in the NumPy package. But the most important thing in this package is going to be the nd array right here. Nd standing for n-dimensional arrays. So this is the most important thing in NumPy, and this is the array. So we're talking about arrays next. Now NumPy is so popular because of the functionalities that its arrays provide. Arrays are kind of similar to traditional Python lists, but they're specialized for data science and big numerical computation. So unlike lists, for example, NumPy arrays are homogeneous, which means they can only store one type of data in one array. We'll talk about that in more detail in a second. Because of its optimization for large data and numerical computation, NumPy arrays are faster than lists in speed and also require less memory space to store the same exact data. It also provides a great number of capabilities that data scientists need on a daily basis. NumPy has a lot of different functions that can be used to create arrays for different purposes. The most basic way of making an array in NumPy is through the np.array function, where we can pass some list, tuple, or other list-like, array-like object. We can pass some object into the numpy.array function, and this will return a nd array. So here we have array1, which is equal to np.array, and we can see this function call right here. We accept one argument. This is one argument. Everything in between this parentheses and this parentheses, this is one Python object. More specifically, this is one Python list, a two-dimensional list. We can see this one big list stores three smaller lists, one small list, second small list, and our third smaller sublist. Each of these smaller lists then store three elements. 1, 2, 3, this is the first small list, this is the second smallest, and this is the third sub-smallest. We pass this big list into np.array and store it inside of array1, and we can see array1 and its type as shown below right here. So this is the array the content of the array 1, 2, 3, 2, 3, 5, 2, 3, 4, 3, 4, 5, as you can see right here. And the type of this array is class numpy.ndArray. So this is a n-dimensional array. Now, typically when we're working with NumPy arrays, a lot of the times we'll be using multi-dimensional arrays to store big data. That's just how we usually use NumPy. Now we can also do the same for floating point numbers. As you can see here, we have a bunch of floats and we pass them into numpy.array through a big tuple. Nothing much different than what we have done here. So we'll print out array 2 and we'll see this right here. We can see all of these are floating point numbers. Now, a moment ago, we were talking about how NumPy can only store one data type in one array. So in a normal Python list, we can store a boolean, a string, an int, a float, a dictionary, a tuple, all in one list. But we can't do that in NumPy arrays because it's optimized for working with big data. So it's got some restraints, which is, for example, we can only store one data type in one array. So for example, if I pass one int and one string into numpy.array, we'll see that the 1 is actually converted into a string. And the reason for that is we can't very well convert the string hi into a int, so it will convert the number into the string. So we can see an array of 2 strings. And if I pass some other data in there, it will also convert it into a string. And here, if we pass 1 and 3.21 into numpy.array, it will convert the 1 into a floating point number. And that's because all of the values of this array will now be floats. It doesn't matter if it's 1, it doesn't matter if it's 2 or 5.38, all of it will be converted to floating point numbers. So 1 point, this is going to indicate this is a floating point number, and 3.21 as the second element. Now let's talk about some of the most commonly used and important attributes of a NumPy array. The first of which is array.shape. This is the dimensions of the array, which is the depth of each kind of dimension. We'll talk about it in a second in more detail. And then array.ndim, this is the number of dimensions. Now technically, this is called axes, but it's really just the number of dimensions of an array. So a 2D array is going to have an ndim of 2. A 3D array is going to have an ndim of 3, etc. Array.size is going to give us the total number of elements in the array. Now this is not exactly intuitive. If you think about it, this array right here, technically it has 2 elements. This is the first element and this is the second element. But array.size is going to give us 8. And that's because array.size is talking about the total number of the smallest elements in the array. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this array is going to have a size of 8. Array.dtype is going to give us the data type that the array stores. So let's take a look at the output when I run this block of code right here. We can see array.shape is going to be 2, 4. Now 2, 4, we can see 2 is going to be the number of elements on the outer list. This list has 2 elements, number 1 and number 2. Now in each of these lists, in each of these smaller lists, we have 4 elements. That's what this 4 is talking about. We have 1, 2, 3, 4. We have 4 elements in each of these smaller lists, and we have 2 of these smaller lists in this entire array. And dim is going to be the number of dimensions. So we can have the first dimension is going to be the 2 small lists. This is the first dimension. And the second dimension is each of these elements. This is the second dimension. So we can see the different dimensions of our array. And also notice how ndim is always going to be equal to the length of our shape array. So if I add, let's just put this in another list. So let's just put another bracket around here. We'll actually see we have 1, 2, 4 because the outer array is only going to store 1 element. So this is the only element in the outer list. And then we have 2 small lists, and then we have 4 elements in each of these smaller lists. Ndim is equal to 3, which is also the size of this list right here, or this tuple, 1, 2, 4. That's 3 elements, so ndim is equal to 3. Let's put this back to what it was before. Now let's talk about size. We already kind of did, right? We have 8 elements in each of these, in this entire array. Each of these numbers counts as 1. So we have a total of 8 numbers. array.d type is going to be int32, which is basically saying that we have integers in this array. If I have 1.2, for example, we can see this is now going to be float64. Let's turn this back into ints, and let's move on to talking about arithmetic operations. Among the many differences between Python lists and NumPy arrays is that arithmetic operations are done element-wise for arrays. And what that means is, well, it's better to just show an example. We have a list here, right? This is a normal Python list with 3 elements stored in a variable called L. We can print out L. Now, if I uncomment this line of code and run it, we can see a type error thrown can only concatenate list and not int to a list. So we're trying to add 2 to the list because we're trying to add 2 to every element. We're trying to turn this into 3, this into 4, and this into 5. Well, we can't do that because we're trying to add a number to a list. We can't do that in Python. So we have to use list comprehension, which is saying for each number in the list, we will add num by 2 and store this in a new list. And we can see 1, 2, 3, and we have 3, 4, 5. Right? Each of these elements have been incremented by 2. 1 has been turned into 3, 2 has been changed into 4, and 3 has been turned into 5. Now with NumPy arrays, what we can do is actually something pretty cool. So we have array, and then we're saying array plus 2. Now you can probably guess that array plus 2 is going to give us 1, 2, 3 turned into 3, 4, 5. Each of these elements have been acted on by the plus sign. So this is called element-wise operation, right? This is the element-wise operations of arrays. So we're adding 2 to every element in this array, and we're printing it out. We're subtracting 10 from all of these elements and printing it out. And we're doing the same thing with multiplication and division, and we can see the outputs right here. And we can also do this with 2 different arrays. So we have array 1, which is A, and array 2, which is B. We have 1, 2, 3, and -1, -2, -3 stored in these 2 arrays respectively. A plus B is going to say 1 plus -1. That's going to give us 0. 2 plus -2, that's going to give us 0. 3 plus -3 is once again equal to 0. We can also do this with multiplication. So 1 times -1 is going to give us -1. 2 times -2 will be -4. 3 times -3 will be -9, as you can see here. To summarize today's lesson, we talked about installing and importing NumPy, creating NumPy arrays using the np.array function, and we also talked about the important attributes of the NumPy arrays, as well as different arithmetic operations that we can perform with NumPy arrays, which is done element-wise instead of list-wise. And that's it for this first video of the NumPy tutorial series on the Future Programmer YouTube channel. I hope you found this video to be helpful, and if you did, please consider liking this video and subscribing to the channel down below so you can learn more about programming. With that said, thank you very much for watching this video, and I hope to see you in more programming tutorials in the future. In the meanwhile, happy programming!